circle, we have two parts, a part for algebra and a part for geometry. So let's start with the coordinate geometry, midpoint formula, distance formula, and the circle formula. Midpoint formula, I have 2 points and I need to find the midpoint between them. So if I join them like this, I need to find the midpoint, this part equal to that part. I need to find this. Any point in the coordinate system has x and y, has x and y. This is x1, y1, x2, y2, x1, y1, x2, y2. But I need this point, which has also x and y. X and y. X is the midpoint here, and y is the midpoint there. That means I can find x using the average between them, right? x1 plus x2 over 2 and y1 plus y2 over 2. If I named this point as M, so the coordinate of the point M, x1 plus x2 over 2 and y1 plus y2 over 2. Yes, and where were you? Where did you go? لسه كنت بسأل رحت فين. ده ميد بوينت فالدنيا سهلة يعني. So x1 plus x2 over 2, y1 plus y2 over 2. Now, distance formula, now you are big enough to understand from where we deduced the distance formula, you know the rule. But from where we got the rule, let's see. As it is a coordinate system, every point in the coordinate system has x and y. So it's also x1, y1, and x2, y2. But here I need to find the distance between them. I need to find this distance. I'm going to name it by D. D for distance. This point has x1 and y1, x2 and y2. I need to find the distance between them. I'm going to complete a right angle triangle like this. That's a right angle triangle here. Now I need to find the distance between them using Pythagoras. What is the distance here? What is the distance? It's x2, but I have to cancel x1 from it. How? Minus. So this is x2 minus x1. What about the vertical part? y2 minus y1. And I can use Pythagoras. So we deduced the distance formula from Pythagoras. When you are young, just memorize the rule. Now you are old enough, you can understand from where I got the rule. So D for distance, Pythagoras, x2 minus x1 square plus y2 minus y1 square, all under the root. Pythagoras. Pythagoras. Clear? Circle formula. I'm gonna move h and go up k. So my coordinates here are called h and k. Why? Because I'm gonna use x and y for something else. So that's h and that's k. Then make a circle with radius r. and any point in the coordinate system has x and y. So my x and y here is a point on the circle, like any point on the circle has x and y. So a point on the circle is x and y, but the center is h and k. So any point in this on the circle is, so I have a lot of x and a lot of y, infinite number of points. And the distance between this point and that point is r. Can we do the distance formula between x and y at the h and k? Y minus k square x minus h square, x2 minus x1, y2 minus y1 under the root equal r, squaring both sides equal r square. So we deduced the circle formula from distance formula. So the distance formula comes from the distance formula from Pythagoras, and the circle formula from the distance formula. x2 minus x1, sorry, it's x and h, x minus h square plus y minus k square equal r square. That's called a circle formula. We can frame them. Like this. Anyone don't understand anything? Midpoint formula, distance formula, circle formula. This part is like the algebra part. تمام؟ مش هتفرق معانا x2 minus x1 أو x1 minus x2، مش هيفرق. Anyone don't understand? Move to the geometry part. طيب هنشرح الجيومتري بارت وبعد كده ناخد الاريا the distance formula. حاضر. الديستانس فورمولا جبناها من بايثاغورس. اي بوينت في الكوردينيت سيستم ليها اكس اند واي، فالبوينتس بتاعتي اكس اند واي، البوينت دي والبوينت دي، وانا عايز الديستانس بين them. فالبوينت ليها x1 واطلع فوق y1، والتانية ليها x2 وهطلع فوق y2، والديستانس بينهم سميتها دي. وعشان اطلع الديستانس بينهم وانا ما اعرفش الرول، رحت مكون بايثاغورس، رحت اعمل رايت انجل ترينجل كده. الحتة دي بقى جت منين؟ جت من x2 لما اشيل منها minus x1. The same way, what about this one? y2 minus y1، صح كده؟ وبايثاغورس ده سكوير بلس ده سكوير ايكوال ده سكوير، صح كده؟ عشان عايز الهايبوتنس، فيبقى ده سكوير بلس ده سكوير ايكوال ديستانس سكوير، احط سكوير روت يطلع الايه؟ الرول بتاعي. كده كلير؟ بايثاغورس، هي بايثاغورس. تمام؟ when you are small grade 7 grade 8 مش هنقعد نشرح لك جت منين، يعني just memorize the rule. نكبر شوية ممكن اشرح لك كل حاجة جاية منين، derivation of the rule. Now let's go for the next part for the circle geometry. Now the geometry for the circle. When the ancient discovered a circle, they got a stick and hold this hand from the stick, this side from the stick, and moved the other side. It moved like this. and made a circle. From this part they made the wheels, the wooden wheels. عملوا منها العجلة بتاعت العربية الكارو، وبدأوا يعرفوا يعني ايه سيركل. ومن هنا جه الديفينيشن بتاع السيركل. ايه الديفينيشن بتاع السيركل؟ What's the definition? Infinite number of points. Can you count the number of points of circle? You cannot. Infinite number of points equidistant from a certain point. Equidistant from a certain point. Now let's have a circle and study what's inside. Infinite number of points equidistant from a certain point. So what do we mean by the certain point here? What do we call it? Turn on your mic and answer me. A certain point, what do we name it? You can turn on your... No, not the origin, wrong. Center right, ya Marwan. Equidistant, what do we mean by equidistant?
Equal
The
distance.
equidistant. What do we name it, this part? No, it's not a chord. It's...
Radius.
Yes, radius. Okay, if I increased it to the rest of the other side, now what we name it?
Diameter.
Diameter. Now what about this one? It's like it but not passing through the center. Chord, thank you. What about its touch? Or make it like this. Touch called what? Touch. Yes, thank you. Tangent. What about cut? مين فاكر? You must know the names. If it comes without text, without any graph, you have to graph it. You must know the words. I'm gonna label them, I know, but I'm just refreshing your memory. The cutting one is called what? Secant. Secant. So this one is called the secant. This one is called radius, diameter, chord, tangent. We're gonna take the arc, don't worry, it will come later. Now let's move to the second part, relations inside the circle. Relations. Now any circle, how many degrees? One complete circle, how many degrees?
360.
360. And any point, how many degrees? Any point around this point, how many degrees? Around this point, how many degrees? Also 360. No, it's 360 also. Around any point is also 360. Any circle is 360 and any point. So if I took from the point a piece, and this arc is also the same piece from 360. That means this angle is the same ratio as this arc. Both of them is the same ratio from 360. That's why the measure of the central angle equals the measure of the subtended arc, because both of them is the same ratio from 360. So the measure of the arc is equal to the measure of the central angle subtended to it. Okay? Now wait يا Jonathan. Who can tell me what about this angle? First step, what is the name of this angle? It has a name, not about letters. This one is called the central angle. What about the other one? This is central angle. What about the upper? It's not central. It's not from the center. It's from the circumference. That's why it can be named as circumference angle. Circumference angle. Another name. The three parts, this one, and this one, and this one, are on the circle. So it's called inscribed angle. Because there its three parts are on the circle, like inscribed triangle, inscribed polygon, inscribed rectangle. That means the vertices are on the circle. So since the three parts of this angle is on the circle, so it's called inscribed angle. So it's either called inscribed angle or circumference angle. Now, what is the relation? Who can tell me the relation? What you are saying about you, Jonathan? What is the relation here? So if I
The angle's doubled.
So if this one is called 120 degrees, this is 120 degrees. This one,
240.
no, 60. The inscribed angle half a subtended arc. Half مش الدبل. It's clear. It's less, not bigger. Cannot be 240. 240 is like this. Okay, it is 60. Half a subtended arc. Half a subtended arc. Now, who can tell me what about this angle? What is the measure of this angle? Either turn on the mic or write. What is the measure of this angle? No, Yarimas. We said that it is an inscribed angle, the three parts on the circle, and the half is subtended arc, so it's also 60. Thank you, Omar. Now, no, wrong, Verena. Verena, it's inscribed, not central. Okay? What about this one? What about this one? Equal كام؟ صح يا ريماز. ما شاء الله، ايه ده كلكم خدتوا. طب ده المفروض دي تريكي شوية بقى. عملتوها المرة دي صح كلكم. That's fine. 60 inscribed angle برضو، بس انا خدتها من الدايمتر عشان ما تاخدش بالك، بس كلكم figured it out. يعني تريك 1 كلكم عملتوها صح طيب. So we have now a theorem. It says that inscribed angles subtended by the same arc are equal in measure. Why? Because all of them have a subtended arc. 120 يبقى 60, 120 يبقى 60, 120 يبقى 60. Right? طيب. Let's move to another one. What? I'm gonna take this side and put it outside as touch. ايه ده؟ Touch. If it's touch, it cannot be inscribed now. Yes. What do we name it and what is the relation? Let's make another figure. touch. It was here. It was like this. Now it's out. It's out. It's touch. وعملته كده from both sides to be clear it's tangent. يعني طلعته من فوق وتحت عشان يبان ان هو tangent. When it was here, this angle is half this arc, right? This angle is half this arc. When it's out, it still has the same property, but different name. Same property means half subtended arc. Half is subtended, but different name. It's called what? Angle of tangency. Angle of tangency. Why? It's tangent. So it's called the angle of tangency, but it still has the same property, half a subtended arc. That means if this arc has an angle 130, for example, so what is this angle? مين بيعرف يحسب؟ Oh, who can calculate with his mind? Don't use a calculator. Huh? Half a subtended arc? No. Yes, Yazan. Joshua, bad calculation. 65. 65. 130 divided by 2. Okay. Half a subtended arc. Okay. Who can tell me what about this angle? Calculators corrupted your memories, your minds. Who can tell me what is the measure of this angle now? Come on. What is the measure of this angle?
130. 150, sorry.
Yes. Yes, no, 130, right. 130 equals the same, equals the arc. It's a 130, not 150.
I can't tell if it's a 3 or a 5.
Okay. It's about my handwriting. Now, who can tell me also what is the measure of this angle? Hmm.
65.
Yes. Now we got all relations. We still have something, but we have 4. Angle of tangency and ascribed angle have the same measure. And central angle and the arc have the same measure, and those, half of those. Angle of tangency and ascribed angle have the same measure, 65 and 65. Arc, central angle have the same measure, and those two angles have those two angles. Clear? Remainder one piece. I name it by Tarbush, the hat. A theorem says that the two tangents drawn from a point outside a circle are equal in length. The two tangents drawn from a point outside a circle are always equal in length. The theorem says because of the two tangents drawn from a point outside, they must be equal in length. They must. Let's see why. Prove it. Let's make a proof. Let's make a proof. To prove it, we're gonna join like this. Then we are gonna make a congruency between this triangle and that triangle. Can we make a congruency? Who can tell me? I need 3 items. Who can tell me the 3 items of congruency? I want one. Just tell me one of them. Which one is clear for you? I need 3 things for congruency. Who can start? No, I don't have. What angle? Which one? There's one angle, but we have to say why. Which one? Angles and sides. Which one is equal to which one? You are right, yes. But which one? And why? One of them is very, very clear. Very clear. Who says 45? I don't know 45. There is one very clear. Radius equal radius. That's number one. Radius equal radius. Huh. Another one. Huh? Common side. This side is common in the first triangle and the second triangle. Remainder one. Huh? I will have a problem in the next topic. Geometry. واضح ان الجيومتري عندكم خربانة خالص. Very nice. Third one. What is the relation? Yes, Rimaz, very good. There is a right angle here. Radius with tangent always 90. Radius with always 90. So I have a 90 here and a 90 here. Radius with tangent and also radius with tangent. So the three parts, radius equal radius, common side is this side is up and is also down, so equal sides, but it's a common one, and 90 degrees because radius and tangent always 90 perpendicular, so we have three. That means they are congruent. From congruency we can say that this side equal to that side. So the theorem is right. The two tangents drawn from a point outside a circle are equal in length. Now it's clear. After any theorem comes some corollaries. Corollaries means result from the theorem. Yes, we have some results here. Why? Because after congruency we can say this angle equal to that angle, and also this angle equal to that angle. And if you joined this side, you will figure out with another congruency that this side equal to that side. Those are corollaries for this theorem. Corollaries, the result from theorem, result from the theorem. Because we made congruency, so those two angles are equal, those two angles are equal. Now we finished the part for geometry. Remainder, area, and the perimeter for a circle. It looks like a mouse, yes. Now, this part is finished. That's all what we need, because some more geometry for a circle, but we don't need them in SAT. Okay? You may need it in ACT, but not in SAT. Now, let's move for the last part, area and the perimeter. area of a circle, circumference of a circle, I think all of you know the rule, right? Area is pi r square, and circumference is 2 pi r, right? Now what about the length of the arc and the area of sector? What's length of an arc or area of a sector? Area of a sector, I need all what's inside. All what's inside. But length of an arc, I need the length only, so I don't need this part. There's always an angle. There is always an angle. My angle here is called the theta, and my angle here is also called the theta. When I take area of a sector, that means I took part from the area. Part is always a fraction. Part is always a fraction. Fraction is a part over whole or a chosen over total. Chosen over, the chosen is theta, and the total a whole degree.
360.
360. So it's the same rule, but multiplied by the fraction, which is the angle over 360. And also the same rule, 2 pi r times the angle over. When you are still small, grade 4 or grade 5, I give you the fraction. 2 over 7 from the circle, 3 over 11 from the circle. Now you are big, I'm going to give you the angle only. And you know that angle over 360 is a fraction of the area or fraction of. Now, let's write the rule. It will be pi r square, it's exactly the same rule. Pi r square times the angle over 360. And here is the same rule, 2 pi r times the angle over. This is the fraction I took from the circumference, and this is the fraction I took from the area. One more piece. What about radians? You said radians, right? Radians, and you know the rules for radians, so I can write it here now. We can write the rule for the radians to be in front of you. Theta degrees over 180 equal theta radian over pi. Can I make a rule using radians? Yes, you can make a rule using radians. What is the rule for here and here? And I'm going to explain one of them, how to derive it, and you can try the other at home. Okay? But you don't need to derivation, just you can memorize. The area of sector and the length of arc using radians here. Length of the arc r theta radian. ايه ده بس؟ ده احلى واسهل. فلو جالك بالراديان يبقى الراجل بصراحه بيكرمك يعني. ار ثيتا راديان يجيب لي اللينس اوف ذا ارك. هعمل لكم بروف لده عشان شوف قد ايه بقى قد ايه. Let's try to derive this one. What about this one? عشان يبقى كده السكرين شوت حلوه فيها كل الرولز. Area of a sector pi r square times the angle of 360 has also in radians. Area of the sector, area of sector، ها حد يعرفها؟ محدش خدها في المدرسة؟ half r square theta radian. half r square theta radian. ده كده ايه؟ ده كده كل الرولز اللي عليك. كده الرولز خلصت. علينا شغل بقى. half r square theta radian. يزن تاني طلع عنده مشكلة في النت. كده that's all rules we have. Let's try to derivate one of them. هنحاول نعمل كده proof جت منين r theta radian ديت. هنحاول نعملها سكرين شوت ونشتغل. انا عندي الرول اهو. هحاول اخد الرول ده واشيل الثيتا ديجريز واحط مكانها ثيتا راديان واعمل لها سمبليفاي ونشوف هتطلع ار ثيتا راديان ولا لا. اوكي طيب 2 باي ار سي 60 خليها هنا. هنخلي بقى دي ثيتا ديجريز صح؟ هنخليها راديان. هنخليها ايه؟ نحط عليها بس علامة الديجريز وهنا علامة الديجريز. عايزين نخليها راديان from this rule. from this rule. انا عايز الديجريز فهودي ال 180 هنا. هتبقى ثيتا راديان تايمز 180 اوفر باي. ثيتا راديان تايمز 180 اوفر باي. هنعمل الكلام ده. هتبقى ثيتا راديان تايمز 180 اوفر الباي. ده كده مكان الانجل دي. تمام. يلا معايا سمبليفاي كده خفيف عشان نعلمك ازاي تعمل ديريفيشن رول محدش يضحك عليك وكل حاجه نحفظ يعني. يلا let's simplify 0 with 0 over 18 over 18 2. ال 2 كانسلد مع ال 2 والباي راحت مع الباي. ايه ده؟ ايه اللي فاضل؟ حد واخد باله؟ الباي فوق راحت مع الباي تحت. 0 with 0 18 with 36 is 2. 2 كانسلد مع ال 2 فاضل ايه؟ ها؟ هو الرول ولا لأ؟ exactly the same way you can try the other one. ماشي؟ اللي هو using radians for الجزء بتاع الاريا. حد محتاج ان اشرح له اي حاجة؟ احنا كده المعلومات خلصت خلاص. anyone need from me to explain. رحت فين يا يزن؟ انت عندك النت فيه مشكلة النهاردة ولا ايه؟ anyone need to explain for you anything else? It's so weak. اوكي. طبعا كل حاجة ريكوردد فاللي عايز يعيد الحاجات دي تاني انا بخليه جزء الانفورميشن بخليه لوحده. وجزء الحل بنخليه لوحده. احنا مش هنحل كل حاجة النهاردة، هناخد جزء بسيط as a homework يعني. تمام؟ مش هديلكوا كله عشان مش هلحق احل معاكوا كل الافكار، وده فيه شوية افكار حلوة كتير. Now